Hi guys, so today we're going to go over relative minimum and maximum, which are the minimum and maximum values giving an interval, which in this case will be the values in this table. So I'm going to give you just a visual of it by graphing these points. So -2 will be at 10, -1 will be at 5, 0, 0, 1, 2 is over here, 2 will be at the point 5, and then 3 will be at the point -3. So um, we have our graph here, and keep in mind that I cannot really draw too well. So, yep, there it is. So just keep that in mind. No judgment. All right, so we can tell the relative minimum and maximum already because the minimum are going to be the values where you have what's called the valleys and the hills. So the hills and the valleys are what I like to call them. So notice from here to here, we have a little dip, which means from -1 to 1, we're going to have our relative minimum, or they can write it from -1 to 1, either way. And then the maximum would be what I call the hill. So if you notice, this will be a relative maximum because of this peak point here. So because of this relative maximum, we have our relative maximum from the point, I would say 1 to 3, just to encompass this peak right here. So this would be from -1 to 3 or -1 to 3. Guys, so today we're going to go over the relative minimum and maximum of a function. So given a table, this will be the minimum and maximum between this interval. So I'm just going to give you a visual of what's happening here by graphing these points. So -2 will have a y value of 10, -1 will be at 5, 0, 0, 1, 2, 2 will be at 5, and you have a point 3 at -3. So if I plot these points and then just sketch it out, I will see my graph here, which will give me the visual of where the relative minimum and maximum are. Think of the minimum as hills and valleys, or the relative minimum and maximum as hills and valleys. So if you look here, you have a little dip, which would be your valley. So this would be your relative minimum. And your relative minimum for this to have this little dip, it would range from -1 to 1. So your relative minimum would be between -1 and 1, or they can note it this way, -1 to 1. For your relative maximum, I should note here relative maximum, it will be the hill. So notice from about here to here, and mind you, I cannot draw, you have your hill. So this peak right here would be your relative maximum, and this would be between the interval points -1 and 3. So between not -1, +1, from +1 to 3. Again, it can be written this way as well. So if you took the table and you graphed it out, you can kind of see your peaks and valleys, hills and valleys, I call them, for your relative minimum and maximum. Now, from here, I'm going to give you a function, and it's asking for what the zeros are. So keep in mind that if you have a function that is already factored, you can set the other side equal to 0, which is the y, and this is what's known as zero product property. So I'm going to write my function out exactly as I see it. And Since the other side is 0 and the right side is factored, zero product property states that I can set each factor equal to 0 and solve. Technically, if x was out here with the 3, I could also set that equal to 0 and solve for x, but since it doesn't have anything here, I'm not going to set it equal to 0 or solve. But everything else I can. And what does this square mean? Oh, sorry, I'm out of room. What does this square mean? It just means that I'll see x minus 1 twice. So this x minus 1 squared means x minus 1, x minus 1. That means that you will see this answer twice. It doesn't actually do anything to affect your answer itself. So I'm just going to set it equal to 0 once because even though I'll see it twice, it's still going to come out as x equals to 1. Here, if I add 2 to both sides, I'll get x equals to 2. And here, if I subtract 1 to the other side, I'll get x equals to negative 1. So these are my x values, which are known as zeros. They are also the x-intercepts, meaning they are the points on the x-axis because remember, you made y or f of x equal to 0. Anytime you have a point where y is 0, that point is going to be on the x-axis, which is known as an x-intercept. Algebraically, when you solve them, we call them zeros, but these words are interchangeable with each other. Also, when they say solve for x, all means the same thing. So the zeros are going to be x equals to 1. You'll see that answer twice, by the way. You can write this as multiplicity equals to 2, but we'll get into that later on. Just a fun fact for now, though. X equals to 2 and x equals to negative 1. Did you have to do it algebraically? No, because if you knew that zeros were x-intercepts, you could also look at the graph and see that this is where x equals, ooh, you can't really see that. This is where x equals negative 1. This point is where x equals to 1, and this point is where x equals to 2. So you can find your zeros graphically if given the sketch itself, or algebraically, especially if it's factored. All right, guys, hope this helps.